Hello students, welcome to Aditya Academy. I am Dr. Ragini Arora and today we are back with the second video of this chapter, Coordinate Geometry. In this video we are going to solve exercise 7.1 from Ncert. In the first video of introduction, I had discussed all the formulae and important concepts about this chapter, and we had solved few questions in that video also. So I hope you must have watched that video. In this video, I'm directly starting with the questions from the exercise, right? So, find the distance between the following pairs of points. The first question is to find the distance. So, it is the direct application of the distance formula. I'm writing it here. Let this be the point P, which is 2, 3. Let the second be Q, which is 4, 1. Distance formula is given as x2 minus x1 whole square plus y2 minus y1 whole square, where x2 y2, like P is point x1 y1 and Q is point x2 y2. Distance is given as PQ by this formula. So here this is 2, 3 is our P and 4, 1 is our Q. I'm simply putting these values in this formula. This is x2 is 4 minus x1, which is 2. y2 is 1. This is x2 y2, x1 y1. y2 is 1 minus 3. 1 minus 3 whole square. So we have 4 minus 2 is 2 square. This is minus 2 square. 4 plus 4, that is root 8. And the simplified version of PQ can be written as 2 root 2 units. We can factorize 8, like 2 4s are 2. So from this pair of 2, you can take out 1 2 common from the square root. This remains inside the square root. This is the distance PQ in the first case. In the second case, let this be P is minus 5, 7. You can denote any other letters also like A, B or C, D. P is minus 5, 7. Q is minus 1, 3. So PQ here becomes x1 y1. This is x2 y2. Minus 1 minus 5. Minus 1 minus 5 whole square. Then y2 is 3 minus 7 whole square. So we have minus 1 plus 5. Minus 1 plus 5 is 4. Minus 1 plus 5 is 4 whole square. 3 minus 7 is minus 4 whole square. So this becomes 16 plus 16, that is root 32. Now for this you can factorize root 32 as this is 16, 8, 4, 2, 2, 1. From two pairs of 2, you can write 2 multiplied by 2 and 1 2 remains inside the square root. So this is 4 root 2 units is the distance between the given 2 points. Third is, let P be A, B. Q represents minus A, minus B. For the distance PQ, the formula becomes x2 minus x1 whole square plus y2 minus y1 whole square. So we simply have to substitute these values. x2 is negative A. Be careful. Then minus is for the formula. Then write x1. x1 is A. Then we have y2. y2 is negative B. Then this minus sign y1. y1 is B. Right? So we have minus a becomes minus 2a whole square. Minus b is minus 2b whole square. So this becomes 4a square plus 4b square. What you can do is, you can take this 4 common and write a square plus b square in a bracket. Now if you take these two numbers are in multiplication. See, you cannot take individual squares when you have numbers in addition and subtraction. But you can factorize when the numbers are in product. So now I have taken 4 common. These are very few things. I have seen where very good students get stuck over few things like this when you have to factorize or taking something outside the root. This has become a difficult area for many students. So factorize into product. Like this is now 4 multiplied by a square plus b square. You cannot do anything about this. You cannot reduce this square and square root. Since this is in an expression which has plus minus signs, this is an expression. You cannot reduce these squares with the square root. You can only deal with these two products, 4 and this whole number. This can be dealt, like 4 can be taken out. Why? Because 4 can be written as 2 multiplied by 2. So out of these 2, 1, 2 can be taken out. So now we are left with a square plus b square inside the bracket. Right? You cannot, please mind it, you cannot reduce these squares with this square root because they have plus minus sign in this expression. Had it been like this, a square multiplied by b square, you would have written a multiplied by b. But we cannot perform this operation in addition and subtraction. So distance here is PQ is 2 square root of a square plus b square units. Next is find the distance between the points 0, 0 and that PB 0, 0, QB 36, 15. So the formula for PQ is, this is x2 minus x1 whole square plus y2 minus y1 whole square. Here your x2 is 36 minus 0 whole square, y2 is 15, y1 is 0 whole square. So what is the square root of 36? 6 6 this is 216, 3 6 18, 1296. Square root of 15, square of 15 is 225. You must learn squares and cubes up to 30 so that these calculations get reduced. This is 1 square root of 1521. Right? So find this square root 1521. I hope you must know this thing that you have to make pairs from right to left. So now this is 3 3s are 9. 15 minus 9 is 6. Then we have 21. Right? 21. Take the double of this 3, which is 6. You have to write the same number here, which we have to write here. So what is that now? You require 1 at the last, right? 67 sevens are 7 sevens are 49. You have 4. 7 6 are 42. 42 and 4 is 46. This is not valid. Now write 6 9 9s are 9 9s are 81 and 8. 9 6 are 54. 54 and 8 is 62. So this is 9, this is 9, this becomes 621. So the square root of 1521 is 39 and you can write units. 39 units. Next question says determine if the points this and this are collinear. Right? So here you have a very important concept to learn. What is the relationship of 3 points if they are collinear? A, B, C. See, just think that here you have A, here somewhere is B, and somewhere here is C. Or you can change their order. You can write C, A, B, B, A, C, C, B, A. The thing is, if you write it this way, if B lies on AC, you can see that the sum of AB and BC will be equal to AC, right? Or if you write it this way, like C lies here somewhere, then the sum of AC and BC would be equal to AB. So irrespective of any order of these ABC numbering, the thing is whenever 3 points are collinear, that means the sum of two parts will be equal to the third part. So that we have to look here. So find the distances of all the three pairs like AB, BC and AC. For AB, I am writing x2. This is x2. 2 minus 1 is 1 whole square. 3 minus 5 is minus 2 whole square. So this is equal to 1 plus 4, that is root 5. Find the distance of BC. BC is minus 2 minus 2. Minus 2 minus 2 is 0 square. Then we have minus 11 minus 3. Minus 11 minus 3 is minus 14 whole square. That is 14 square only 196. That becomes 14 itself. Then we have AC or CA. You can find it anyway. AC. So minus 2 minus 1 is minus 3 whole square. Minus 11 minus 5. Minus 11 minus 5 whole square. So what we can do is, this is 9. Minus 11 minus 5 is minus 16 square. Minus 16 square. So we have 9 plus 16 square is 9 plus 16 square. 16 square is 256. Right? So this becomes 256 plus 9 is 265. Right? Now if you can simplify this, this is 265. 5 5s are 25 and 15. 5 3s are 15. That means this cannot be solved further. So we can see that this is square root of 5. This is 14 and this cannot be solved further. Since now we are trying to factorize this root, square root of 265 cannot be factorized to get some number outside, and you cannot add these numbers. So we can see that here we cannot see neither AB plus BC is equal to AC, right? Neither we have AC or AC plus BC is equal to AB. So we are not getting any two smaller parts equal to the bigger one. So we can say that they are not collinear. They are not collinear. Right? The next question is, check whether these 3 points are the vertices of an isosceles triangle. I'm trying to locate them on the triangle. Whether it is isosceles or not, that we will check. Let A be 5, minus 2. B represents 6, 4. C represents 7, minus 2. Now for that we have to find the lengths of all the three sides of this triangle. Let AB is equal to, AB represents, for this you have B as x2 by 2. 6 minus 5 whole square. 4 minus 2. 4 plus 2 whole square. This comes out to be 1 square plus 6 square. that is 1 plus 36, that is root 37. Then we have BC. BC is, what is this? Is x1, y1, x2, y2. 7 minus 6. 7 minus 6 square added to minus 2 minus 4 whole square. This comes out to be 1 square plus minus 6 whole square. That is also equal to 1 plus 36, that is root 37. Next we have AC or CA. CA is 5 minus 7 is minus 2 whole square. Added to minus 2 minus minus 2, that means plus 2 whole square. Right? So this comes out to be, this is 4 plus 0, that means square root of 4, that is 2. So we had to check only for isosceles triangle, though we were done here only. Right? So we can see that in an isosceles triangle, if AB and BC are equal, here AB is equal to BC. That means two sides of a triangle are equal. Yes, they are. Yes. These are the points of equilateral triangle. Yes, they form an isosceles triangle. They form an isosceles triangle. Since two sides are equal, this is an isosceles triangle. Okay, this question is having a figure. In a classroom, 4 friends are seated at the points A, B, C and D. As shown, Champa and Chameli walk into the class, and after observing for a few minutes, Champa asks Chameli, "Don't you think ABCD is a square?" Chameli disagrees. Using distance formula, find which of them is correct. So before starting this question, first of all, you have to, this is a very good question, you have to find the address of these 4 points, like write the coordinates of these 4 points on the given picture. So this is nothing but the simple graph that we have learned. The only thing is all the points are having the positive coordinates. All the points right now are in the first quadrant. So the coordinates of A, you can read. See, A is here. A is here. Now read the coordinates. What is the x coordinate? Okay, let me change the color. For this, what is the coordinate of A? For A, you have to check. This is your x-axis and this is your y-axis. On x-axis, first you have to come 3 units. This point has fall perpendiculars on x-axis and y-axis. We will get the coordinates. On x-axis, you are getting 3. So the first coordinate is 3 and on y-axis it is 4. This is 3, 4. For B, where is B? B is here. For B, put perpendicular here, reading here is 6. So B, x coordinate is 6. And on y-axis, the reading is coming out to be 7. Then we have C. C is here. For C, perpendicular here is showing 9. It is 9 on the x-axis. And from here you can read 4 on the y-axis. For D you have perpendicular here is 6. It is showing 6 on x-axis and read this point 1 on y-axis. So now we have located all the 4 points in terms of their coordinates. And we have to check whether this is a square or not. So we are going to find the distances or lengths of AB, BC, CD and DA. AB is x2, 6 minus 3. 6 minus 3 whole square, 7 minus 4, y2 minus y1, 7 minus 4 whole square. That is 3 square plus 3 square. This is 9 plus 9. Root 9 plus 9 is 18. You factorize 18. This is 2 nines are 3 threes are. So now this is 18. So we can write 3 root 2 units. Now we have BC. BC is 9 minus 6 whole square, 4 minus 7 whole square. So this is 3 square plus minus 3 square. This is 9 plus 9, root 18. Again we have 3 root 2 units. Then CD. CD is 6 minus 9. 6 minus 9 square, 1 minus 4 square. So we have 6 minus 9 is minus 3 square. 1 minus 4 is minus 3 whole square. So again we have 9 plus 9, that is root 18. These three sides are equal. Then finally we have DA. DA means 3 minus 6. 3 minus 6 whole square. 4 minus 1. 4 minus 1 whole square. This is negative 3 square plus positive 3 square is again 9 plus 9 is root 18, which is 3 root 2 units. So you can see that all the four sides of this quadrilateral are equal. But in this case, it may be a rhombus also. So he's asking whether it is a square or not. Let us confirm that AB is equal to BC is equal to CD is equal to DA. All the four sides are equal, and to confirm it for a square, we can find the length of the two diagonals. If the diagonals are equal, it is always a rectangle or square. So this cannot be a rectangle. It will be a square if the diagonals are equal. For diagonal, we have to find AC and BD. What is AC here? AC is 9 minus 3. 9 minus 3 square added to 4 minus 4 square. That is 6 square plus 0. This is 6 itself. Then we have BD. BD is 6 minus 6. 6 minus 6 square added to 1 minus 7 square. So we have 0 added to 36, which is 6. So AC and BD are also equal. AC is also equal to BD. So we can say that ABCD is a square. Right? That means if you have to prove a quadrilateral being a square, all the four sides should be equal. Moreover, both the diagonals should be equal. Right? Next question is name the type of quadrilateral formed, if any, by the following points and give reasons for your answer. Here we have to look for some special kind of quadrilateral if it can be formed from these 4 points. Minus 1, 2. This is D, which is minus 3, 0. So first of all, we have to look for the lengths of all the sides of the quadrilateral. That is AB. AB is 1 minus minus 1 is 1 plus 1, 0. 0 minus minus 2 is 0 plus 2 square. This is 2 square plus 2 square. That means 4 plus 4 is root 8. That means 2 root 2. Now comes BC. For BC it is minus 1 square. 2 minus 0 square. That is minus 1 is minus 2 square. Minus 2 square plus 2 square, that is 4 plus 4. This is also root 8. So we have 2 root 2. Then we have CD. CD is minus 3 minus minus 1 is plus 1 square. 0 minus 2 square. So we have minus 2 square added to minus 2 square. Again we have 4 plus 4. So it is root 8, which is 2 root 2. Finally we have dA. dA is minus 1 minus minus 3. Minus 1 minus minus 3. Minus 1 plus 3 square. Minus 2 minus 0 whole square. So we have 3 minus minus 2 square plus minus 2 square is 4 plus 4 is root 8, which is 2 root 2. So you can see that all the four sides of this quadrilateral are equal. But now this can be a rhombus or it can be a square. Now for confirming it to be a square, we need to check the lengths of two diagonals. For that I am finding AC. AC is minus 1 minus minus 1 is minus 1 plus 1 square. Then 2 minus minus 2. 2 minus minus 2 is 2 plus 2 square. So we have 0 plus 2 plus 2, 4 square is root 16, that is 4. Then we have BD. For BD, minus 3 minus 1. Minus 3 minus 1 square added to 0 minus 0 square is again negative 4 square, which is 4 itself. So we can say that AB is equal to BC is equal to CD is equal to DA. All the four sides are equal. Also, AC is equal to BD. Therefore, ABCD is a square. Right? Next we have these 4 points A, 0, 3. D is minus 1, minus 4. So again we have to find all the sides first. AB is square root of 3 minus minus 3 becomes 3 plus 3 square. Then we have 1 minus 5 whole square. That is 3 plus 3 is 6 square. Added to 1 minus 5 is minus 4 square. 6 square is 36. Added to 4 square is 16, which is root 52. Right? Now see if you can factorize root 52 or not. 52 to 26 to 13. So we can write this as 2 root 13. Right? You can see here this is 2 times 13. So you can take this 2 from this pair of 2, you can take 2 common. This becomes 2 root 13. Then we have BC. BC is 0 minus 3. Then 3 minus 1 whole square. So it is 0 minus 3 is minus 3 square added to 2 square. That is 9 plus 4 is root 30. Then we have root CD. CD is square root of minus 1 minus 0 square and minus 4 minus 3 square. 1 square added to minus 7 ka square. Then we have 1 added to 49. 1 added to 49 is root 50. Now root 50 can be factorized as this is 25, 5, 5, 5, 1. So you can write this as 2 multiplied by 5 multiplied by 5. Write this as 5 root 2. right? Then we have DA. DA is, from here you can see that there is no relationship between these. Let us find the last one also. DA. Minus 3 minus minus 1. Minus 3 minus minus plus 1 square. 5 minus minus 4. 5 plus 4 whole square. So we have minus 3 plus 1 is minus 2 square. This is 9 square. This is 4 plus 81. So we have root 85. 85 cannot be split into different numbers because 17 fives are both are prime. So this is root 85 itself. Now you can see that there is no relationship between these sides. So this is a quadrilateral. Quadrilateral means any four-sided polygon. Quadrilateral. It may form a quadrilateral, but it is not a parallelogram or some special parallelogram like rhombus, square, and rectangle. It is a normal quadrilateral. Next part is, let A be 4, 5, B is 7, 6, and D be 1, 2. So here we find all the sides first. AB is 7 minus 4 whole square. 6 minus 5 whole square. So we have, this is 3 square added to 1 square. 9 plus 1 is root 10, right? Then we have BC, 4 minus 7 square added to 3 minus 6 square, which is 4 minus 7 is negative 3 square added to 3 minus 6 is also negative 3 square. So we have 9 plus 9 is root 81. Root 81, sorry, this is 9 plus 9 is 18. 18 can be written as 3 root 2. Then we have CD. CD is 1 minus 4 whole square, 2 minus 3 whole square. This is negative 3 square added to negative 1 square. That is, negative 3 square is 9 added to 1. This is also root 10. Finally, we have DA. DA becomes 4 minus 1. 4 minus 1 square. 5 minus 2 square. This is 3 square added to 3 square. 3 square is 9 added to 9 is root 18, which is also 3 root 2. So now you can see that here AB is equal to CD. AB is equal to CD and BC 3 root 2 is equal to DA. BC is equal to DA. You can assume this to be like this. A, B, C, D. AB is equal to CD and AD is equal to BC. So this is right now forming a parallelogram because opposite sides are equal. Now if we have to, now this parallelogram can also be a rectangle in case the diagonals are equal. For this question, you must remember all the properties of parallelograms and special parallelograms like rectangle, rhombus, and square. In square also diagonals are equal, and in rectangle also diagonals are equal. So this is a parallelogram for sure. But whether it is a special kind of parallelogram like rectangle or not, we need to check for diagonals. AC is 4 minus 4 square added to 3 minus 5 square. Right, so this is 0 added to 3 minus 5 is negative 2 square, that is 4, so this becomes 2. Then find BD. BD is 1 minus 7. 1 minus 7 square added to 2 minus 6 square. So we have minus 6 square added to 2 minus 6 is negative 4 square. They are not equal. 36 plus 16 is root 52. So here we can see that ABCD is a parallelogram. Because diagonals are not equal, so this cannot be a rectangle. This is a normal parallelogram in which opposite sides are equal. Next question is, find the point on the x-axis which is equidistant from these two given points. Okay, so we have to find a point P. P is equidistant, x comma y is equidistant from the point A, which is 2 comma negative 5, B, which is negative 2 comma 9, right? PA has to be equal to PB. So here we have to apply the formula that PA is equal to PB, and accordingly we have to find the point P. What is the special thing about P? Find the point P on the x-axis. Here is a clue, right? Otherwise, if we put the values of x and y over here, we will be getting an equation in terms of x and y, two variables, right? What we can do is, we can reduce that complexity by taking the point of this format. Since P, you have to write here, since P lies on x-axis, therefore P will be a point of the form. On x-axis we know that the point is of the form a comma 0, where a is the coordinate of that x point, and since all the points on the x-axis have their y coordinate 0, so the point will be of this format, right? So now I am modifying my value. I am writing this as a comma 0. This you have to understand. All the points on x-axis have their y coordinate 0. All the points on the y-axis have their x coordinate 0. Let P be x comma y, which becomes a comma 0 due to this special property. So now applying, you can remove this and the P gets modified as a comma 0. I am using this P in the formula. PA is 2 minus A. 2 minus A whole square added to minus 5 minus 0. Right? PB is minus 2 minus A. Minus 2 minus A whole square added to 9 minus 0 whole square. So this is the whole expression that we have got from the given things. The point P is equidistant from A and B. That means the distance of PA and PB has to be the same. So PA is equal to PB. Moreover, the point lies on the x-axis. That means the y-coordinate of this point is 0 and I am assuming the x-coordinate to be A. So this is the relationship that we have got. Now after putting these values, since we have the whole square root on both the sides, we can reduce it. 2 minus A whole square minus 5 minus 0 whole square. This is equal to minus 2 minus A whole square added to 9 square. Now I am opening these brackets. This is A square plus B square minus 2AB minus 4A. And minus 5 square is 25. Since these, see now here we have basic thing like minus 2 minus A whole square. Don't consider this as A minus B whole square. Both the terms are negative. What I can do is taking minus sign outside. When I take the square of this number, this is negative. So the square becomes this thing only. Square of minus sign, it becomes positive, and square of 2 plus a square is written as this. So don't get confused. Generally, children make this mistake in doing this calculation. This is 4 plus a square minus 4a added to 25. This becomes a square plus b square plus 2ab. 2 into 2 into 4 is 4a plus 81. A square 4 and a square 4 get reduced. This minus 4a, this 4a comes here, becomes negative. This is 81. This 25 goes here in minus sign. Minus 8a is 11 minus 5 is 6. 7 minus 2 is 5. And this is positive. So a becomes 56 over minus 8. So a is minus 7. Right? So the point P is represented as a comma 0, which gives us P is minus 7 comma 0. This is the point P, which is such that PA is equal to P. Next question is, find the values of y for which the distance of the points P and Q is 10. Okay, so see, we have a point when the values of y for which the distance between the points P is 2 comma minus 3, and we have Q is 10 comma y. The distance PQ is given as 10 units. So we simply have to put the formula P is 2 comma minus 3, Q is 10 comma y, and distance PQ is given as 10 units. So the formula is PQ is square root of x2 minus xy1 whole square, y2 minus y1 whole square. I am putting this formula. PQ is 10. Now substitute the values. X2 is 10. 10 minus 2 whole square. Then y2 is y minus y1 is minus 3. So it becomes y plus 3 whole square. Right, now here what we have to do is we have to find the value of y. So the RHS here is under the root. So what we can do is squaring both sides. Squaring both sides. That makes it 10 raised to the power 2. And if you take the square, this is 8 square plus y plus 3 whole square. Take the square. This whole square gets reduced by the square root. So this becomes 100. Now since this square root has been removed, I am opening this. 8 square is 64. This is a plus b whole square. A square plus b square. 2 3s are 6 y. So now y square plus 6y. 64 plus 9 is 73. This 100 goes to that side in minus. This becomes 0. So we have y square plus 6y minus 27 is equal to 0. To find y, we have to factorize the LHS. For middle term split, this is minus 27 into 1 is minus 27. For the factors, the product is negative 27. One of them is negative, one of them is positive. Sum is positive, the bigger one has to be positive. So factors of 27 are 27 and 1, 9 and 3. Right? 9 and 3, keeping 9 positive and 3 negative, we get 9 times minus 3 is minus 27. 9 minus 3 is positive 6. So we can write this as 9y minus 3y minus 27, 0. From these two terms, I am taking y common, so we have y plus 9. From these two, we have minus 3 common, so we have y plus 9. Now y plus 9, this whole bracket is common, so we have y minus 3 is 0. The values of y comes out to be negative 9 or positive 3. So y is negative 9 or 3, right? We had to find the values of y only. Next question is, if q is equidistant from the point P and R, find the values of x, right? If q is the point 0, 1, which is equidistant from P and R. P is 5, minus 3. R is x, 6. They are equidistant. That means PQ is equal to QR. P is 0, 1. Sorry, this is Q is 0, 1. QP is equal to QR. This is 0, 1. P is right. Q is 0, 1. P is 5, minus 3, and R is x, 6. So now we are given that Q is equidistant from P and R. That means Q is equal, distance of Q and P is equal to distance of Q and R. QP. What is QP? QP or PQ. PQ is 0 minus 5. 0 minus 5 whole square. Then 1 minus 3 is 1 plus 3 whole square. Then we have QR. QR. X minus 0 added to 6 minus 1 whole square. So in this case also you can see that we have square root on both the sides. The whole left hand side and right hand side are under the roots. So we can square both the sides or remove the square root on both the sides. So we have minus 5 square added to 4 square. X square added to 6 minus 5. 1 is 5 square. So we have 25 added to 16 is equal to x square added to 25. So they are getting reduced. So x square is 16. You can say that x is equal to plus minus 4. So x can be negative 4 or positive 4. Right? So values of x have been found. Also find the distances QR and PR. Okay, now since x is minus 4, so what we have to do is QR becomes, R is, let's say this is negative 4, 6 and positive 4, 6. It can be any value. X can be negative 4 or positive 4. So QR, find the distance QR. What is R? I am taking this as the first one. Negative 4 minus 0 square. Then 6 minus 1 square. So we have minus 4 square added to 5 square. That means 16 plus 25 is root 41. QR and PR in the same case when x is being taken as negative 4. PR, P and R. So we have, let this be minus 4 minus 5 square, and this is 6 minus 3. 6 minus 3 is 6 plus 3 whole square. So we have negative 9 whole square and positive 9 square. That is 81 plus 81, that is root 162, right? And for the second pair, here I have found these values for minus 4 comma 6, and by taking this as r as 4 comma 6, what would be the value of qr? Qr is, now take this value, leave this, 4 minus 0. 4 minus 0 square added to 6 minus 1. 6 minus 1 whole square. So we have 4 square added to 5 square, which is 16 plus 25 root 41. And then PR. PR becomes 4 minus 5. 4 minus 5 whole square added to 6 minus 3, 6 plus 3 whole square. So we have minus 1 square added to 9 square, which is 1 plus 81, that is root 82 units. Right? So these are the different 4 values according to 2 different values of x. Now the last question for this exercise is, find a relation between x and y such that the point xy is equidistant from the point 3, 6 and minus 3, 4. This is also similar kind of question. Let P be xy. The coordinates of P be xy, and this point is equidistant from the point, let's say A, which is 3, 6, and B, which is minus 3, 4. So here also you have to, since we have 2 variables here and no specific, like in few questions we were given that the point lies on the x-axis or y-axis. Here it is a general point, so both the coordinates are unknown. So we will not be able to calculate this for the value of x or y. So we have to leave the relationship in terms of an equation. The question says, find a relation between x and y. That relation will be in the form of an equation. We will be solving this question. Let's see. The condition is the point is equidistant from these 2 points. That means PA is equal to PB. Right? So now I am applying this formula here. PA. This is 3 minus x whole square. 6 minus y whole square. This is negative 3 negative x whole square. Then we have 4 minus y whole square. So the question says point P is equidistant from A and P. That means distance PA is equal to distance PB. I have simply put the values of all the 3 points in the given equation. Now the whole LHS and RHS are under the roots, so we can remove them from both the sides. So we get these brackets outside these roots. Sorry. Now here also, when both the coordinates are negative, you can simplify this like negative 3 negative x whole square. How this is equivalent to 3 plus x whole square, I am explaining you. Take this minus common from both the terms. Both of them become positive. You have the square of this whole thing. So when you take the square of a negative number, it itself becomes positive. So this becomes positive, the square is only left on this bracket. So this is equivalent to this. So I am replacing this by 3 plus x whole square. Only implement this when both the terms are negative, not in this kind of questions, right? Now open these brackets. This is a square plus b square minus 2ab. A square plus b square minus 2ab. On the right hand side, this is a square plus b square plus 2ab, 6x. A square plus b square minus 2ab is minus 8y. X square, y square, x square, y square got reduced. So we have negative 6x, negative 12y, 9 plus 36 is 45. Simplified LHS. This is 6x, negative 8y, 16 plus 9 is 25. Now we simplify it further. This is negative 6x, negative 6x, negative 12y. Since 8y goes here, becomes positive. This is 45. This 25 goes here, becomes negative. So we have negative 12x, negative 12 plus 8 is negative 4y, and this is 45 minus 25 is 20. Now what we can do is we can take negative 4 common from here. So we have 3x, this becomes positive y. Negative 4 has been taken. This becomes negative 5. So this negative 4 is brought down to right hand side, becomes 0. So the relationship is 3x plus y minus 5 is equal to 0. So this is the relationship between x and y. This relationship is 3x plus y minus 5. We had to find the relationship between x and y. So it can be expressed in the form of this linear equation. This is a linear equation in two variables. So now we are done with the exercise 7.1 of this chapter. I hope these questions are clear to you. And if you are finding anything difficult in this video, please go back to the introductory video. I have explained the concepts in very minute details in that video. I hope you liked watching this. Please subscribe, like and share it with your friends. Thank you.